Okay, so where we left off is that we figured 3 out of how many? 1, 2, 3, 4, 5, 6. 6 irreducible representations. And I know that there's 6 irreducible representations because there are 6 classes of symmetry operations. So we have to find the other 3 before we can proceed, right? And so there's a number of ways you could do this. At this point, you could actually just solve it by inspection. So you could try different numbers and figure out where you are using your other 4 rules, okay? And so that takes some trial and error. And that's actually how we're gonna do gamma 5 and gamma 6. But I wanted just to show you another function you can use. Now I mentioned you can use X, Y, and Z. We did those for this character table. You can also use quadratics or cubics or anything you can imagine, although sometimes those get more complicated and don't actually really help you. But another one you can use is a rotation vector. And so imagine the rotation function or rotation vector. Just imagine this as a single-headed arrow bending in one direction. So if we have RZ, the RZ function is going to be a rotation arrow clockwise, okay, and it's wrapping around the Z axis. And so all you're going to do here is think about how this RZ vector transforms. And if it's, cleanly, it's not transforming into linear combinations of things, not transforming with some other function, you could get very easily an irreducible representation. So obviously, if you do the identity on any function, including RZ, you're going to get back itself. So that gives a character of 1. We put in a 1 there under the identity. Now, what if we do a C3? That's a C3Z. That is a rotation, a clockwise rotation, 120 degrees of the C3. So you're going to have this rotation vector, and now you rotated it further clockwise. Well, it's already pointed clockwise. If you rotate this further clockwise, it's going to end up looking like that, right? And that's essentially the same function. That's still just a clockwise rotation around the Z-axis. So nothing changed there. So doing C3 just went RZ to RZ. So again, we're going to have another 1 right there. What about a C2? Now, a C2, this is a perpendicular C2, right? So now you're taking this RZ that's pointed with the arrow on one end, and you're flipping it. And so that turned it into actually a different direction, okay? And because basically this became this. You rotated that whole arrow, okay? And so that became the negative of it. Now the arrow is pointing counterclockwise. So it went to negative RZ. So the character under C2 is negative 1 right there. Inversion. Okay, inversion's a little bit tricky to think about. But we always just use our definition that we always have. And so I'm going to try to draw this here. So here we're in the front, right? And we're in the kind of the middle. Looking, this is right here. And we know that always we go to the opposite. X, Y, Z, and for inversion goes a negative X, negative Y, negative Z. So the arrowhead here is sort of in the front, in the middle. So what does that mean? If we're going to do the opposite of that, the arrowhead is going to go to the back. And what's the opposite of the middle? Well, middle is in the middle. So opposite of the middle is middle. Okay, it's not left, it's not right. So it's going to go back, middle. So the arrowhead area is going to go there. That's the end of the arrow. I'm just going to put a dot for now. Now, what about the start of the arrowhead, the whole arrow? That was in the front. That was in the back, sorry, right? It's right here. It's in the back and the middle. So opposite back middle is front middle. So the beginning is going to be there. Okay, and now what about here? Let's take a middle point. That's in the right, and it's not in the back or the front. It's sort of now a different type of middle, but it's right middle. So it's going to go to left. And so if you follow all this, we're going to start here. This is the middle point of our trajectory. And then where we figured out the arrowhead was there. And so you ended up with something that was going clockwise, right? And now this is just a continuation. It's going clockwise. So inversion actually for RZ here isn't doing anything. We just went from a clockwise arrow and we ended up when we inverted it, we went through this negative X, negative Y, negative Z thing, where we thought about the opposites in space. That went to negative. That went to the clockwise as well, went to this picture. So that's gonna be 1. These can be a little bit hard to visualize. So if you like these, they can be really a good way to solve the problem. But like I said, you can also Sudoku it out, as I'll show you in a second with the other 2 vectors, irreducible representations, gamma 5 and gamma 6. But anyway, that's why we have a 1 here under inversion. S6, let's think about S6. Well, S6 is a C6, right, followed by a sigma H. So if we do a C6, that's just rotating this clockwise along the Z. Just like for C3, that's going to be doing nothing. And now you're going to take a mirror plane. So you have this arrow here, and your mirror plane is a sigma H. It's cutting through. It's horizontal to the principal rotation axis. It's cutting straight through that arrow. The arrow is actually in the mirror plane. So anytime you have a vector that's in a mirror plane, it doesn't do anything. So we did, the C6 did nothing, and the sigma H did nothing. So overall, we did nothing. So RZ went to RZ, so we have a character of 1 under S6. Last one is sigma D. Sigma D's, remember, cut through, okay? And so you have something that's, the arrow is being cut through by a mirror plane. And so that's gonna flip the arrow head. Sorry, I drew that wrong there. That's gonna change the direction, okay? That's gonna flip the arrow head. This part in front of the mirror is gonna go to the back, okay? And this part in back is gonna go to the front. And so net, now you're rotating the other way. You're rotating counterclockwise. So that gets us this last 1. Okay, and for the last 2, all we're going to do is, we could test other functions, but we're just gonna use some of our rules. We didn't even use rule 1 yet, and that's a great one to use. So we know that the sum of all these columns is going to, the sum of the squares of them has to be equal to 12, which is the order, right? And so the only way to get that with whole numbers that are non-zero and non-negative is with one of these being a 1 and one of them being a 2. So that solves these. And again, whether or not I put a 1 here or 2 there, it doesn't matter. Again, the ordering of the rows is totally arbitrary, okay? And then I just applied rule 2, or you could use the orthogonality rule and checked to make sure that all these vectors work, okay? And there's also some patterns in the table that you'll start to see. So you get some practice on these sorts of problems, you'll see them very easily. Last thing is to assign Mulligan symbols using the rules very quickly. Remember that the A's or B's are one-dimensional ones, so all these 1s got A's or B's. The E's were 2-dimensional ones with dimensionalities of 2. Sorry, I should be using the word dimensionality. So these 2 with 2's under identity got E's for the Mulligan symbol. The 1s and 2's are whether or not you're symmetric or anti-symmetric with respect to the principal rotation axis, which is C3. So the 1s here, ones or 2's, symmetric with respect to the principal rotation axis tells you whether or not you're an A or a B. And so we don't have any B's here because we have all 1s. We have a 1, a 1, a 1, and a 1. So all these are A's, none of them B's. And then the 1 or the 2 is for a perpendicular C2. And if you don't have a C2 like we didn't have before, then you go to mirror plane. But we do have a perpendicular C2. So the 1s for the C2s have 1s, and the negative 1s, these 2 have the 2s, A2s. And then you can see that if you have a 0, that's not really symmetric or anti-symmetric. It's something else, right? We don't have a name for it. And so that didn't give a 1 or a 2, just doesn't have a symbol. And then lastly, you have the U's and the G's, the garatas and the ungaratas. And so those you look for the symmetry with respect to inversion. All the ones with the negative ones or the negative twos, those give you U's, okay, they're anti-symmetric. And all the ones with the positive values, those give you G's. And that's it. So, you know, definitely a lot of visualization, a good deal of math in here. Takes a lot of practice. This is definitely, you know, a harder example. So I probably won't give you, or I'll tell you, I won't give you one this difficult on the exam. But if you can solve this one and you understand it, you'll do totally fine on that first problem of the exam. And, you know, there's not that many problems on the exams because all the problems are very long. So you'll do pretty well on the exam if you can do this one. I'd like you to practice the C2H character table, and you can do other ones. This is walking you through the different symmetry operations, and there's the answer. See if you can get that. It's a lot easier than the D3d. We can go over both the D3d and the C2H character table in class.